All right, we're back. And I've got the test up on the other screen, which I'll try to get to. All right, why am I not getting to the other screen? Because I should be over here. Here we are. And we have anything else from this particular test? I have to request this be our last segment. I'm running out of gas. It's been a long day. I started at 5.
So, Professor, remember how we did the easy isomer, I guess, last time?
The easy isomer.
Not isomer, I mean chair, sorry.
The chair. Oh, it's time to move back to the trickier chair. One with R and S in it. Yeah. Do you want to do just the one that's here?
Yeah, that's fine.
Yeah. So we'll snip the original question here. Okay, snip. Where'd you go, snip? Let's come on. Oh boy. Oh, there it is. It's way over there. And let's grab that and put it starboard. Where'd you go? There we are. And then we'll grab the second chair. And that was over here. And snip is still over here. All right. Okay, so this is spring 18 T1 part 4. And like yours, it will be the second chair with stereo centers in the name. And so you can just cross this one off. You're not even going to get this one. You're going to get 5 points for each of your chairs in the second one. And before you start, don't start drawing chairs now. No. Start here. This is not even worth points, but if you don't do this, there's a chance you're going to lose a lot of points. I'm not even starting with a chair. I got to figure out if the stereo centers have groups up or down. So I'm just moving the old start here up so I can see the question. But it's not, this is not part of my answer. We're putting an 4-iodo-butyl group on carbon 1. You pick carbon 1. Why not make it top right? And we also need carbon 3. So we have an iodo-butyl. How do you draw that? Well, you draw the butyl first. 1, 2, 3, 4, with an iodo off of the last one, the fourth one. And on carbon 3, we draw our friend neopentyl, which is CH2, then your chicken foot. And don't forget, there's an H on each of these stereo centers. And remember what I told you about doing R and S? Notice I didn't do wedges and dashes yet. We have to decide our priorities and connect them. And if I connect the priorities 1, 2, and 3 off of stereo center 1 and I get clockwise, I'm going to put the H on a dash. If I connect 1, 2, and 3 on stereo center 1 and get counterclockwise, I'm going to put the H on a wedge. And that's the only 2 possibilities. Okay, I need it to be clockwise if this is on a dash, or counterclockwise if this is on a wedge, because then it won't be S, it'll therefore be R. And I'm just doing a lot of talk. It's probably best illustrated if I do this problem. Priority 1 might surprise some people because they didn't do a thorough reading of how to do stereo centers and they jumped right to doing problems on exams. This iodine is not part of the picture when I'm comparing this carbon to this. They're both CH2s. They're both tied. This CH2, what's the heaviest thing on it? A C. This CH2, what's the heaviest thing on it? A C. So we're still tied at this distance. What's the heaviest thing on this C here? A C. What's the heaviest thing on this C? A C. We're still tied at this distance. What is the next heaviest thing off this C? A second C. What is the next heaviest thing off this C? You've already counted that. You can't count it again. The next heaviest thing is an H. This H loses to this C. So we have priority 1 here. And I'm pretty sure this is 2, but I got to verify it. Pretty sure that's a 2, and this is a 3. Let's go through the steps. How many CH2s are tied? CH2 once, twice, 3 times, 4 times. CH2 once, twice, 3 times, and it's not really a CH2, but it's the same distance away. So now you're comparing this C in green. Nah, green's bad choice. To purple. This C is the same distance from the stereo center as this C. What's the heaviest thing on this C? A C. What's the heaviest thing on this C? An I. 127 grams per mole versus 1 gram per mole. That's why this is the 2 and this is the 3. And clearly this is the 4. And you might think it's tricky. If you do, then you need to do more practice on stereo centers. It gets better, but you have to practice them. You can't look at them and do them. You have to practice them. And I was lucky. No, I wasn't. There's no such thing as lucky and unlucky. I connect 1, 2, and 3, and I get a counterclockwise connection, indicating that if I put the number 4 group on a dash right now, this stereo center is S. I don't want S. I need the R version. The fix is very easy, everybody. Put the H on a wedge. More importantly, you're putting the number 4 group on a wedge and pick an adjacent bond for the dash. And please don't pick one of the cyclohexyl bonds. The reason we do chairs is because we don't do wedges and dashes in the chair. So just adjacent there. So that'll be up and this will be down. In case you didn't know and you haven't watched the other videos yet, a wedge is the same as up and a dash is the same as down. When you're doing chairs, it's all about ups and downs, isn't it? All right. So stereo center 3 needs to be S. Well, clearly the number 4 is the H. Light pink doesn't show up well. How about orange? And which of these CH2s is going to be a higher priority? There's 3 of them. I don't even like this one. It doesn't hit anything for a long time. These CH2s hit something the same distance away. And tell me why I like, for number 1, I like this one better than this one. Oh, sorry, I take that back. Why do I like this one better than this one? And the answer is forthcoming. Here we have a CH2 tied with a CH2. What's the next heaviest thing? A C. Next heaviest thing here, a C. This has nothing but C's. The first 2 C's tie, and the third bond is the H, which loses. So 1 is better than 2 because this thing doesn't have any H's on this C. 2 and 3 is a CH2 that doesn't hit a branch for a long time. And was I lucky again? I was lucky. It's not about lucky. Hey, it's already S if the 4 is on a dash. What do? Put the 4 on a dash. Adjacent bond off the ring wedge. Hey, I finally figured out this molecule is trans. This group is down and this group is up. And no, don't draw just any trans. When you draw it, you better make sure the one on 1 is a down and the one on the 3 is up. Now you're ready to start your answer. And I'll put the answers here. 2 nice chairs. You've been practicing. Please make sure those are on angles and not straight up and down. And make sure those go more than halfway across. Yeah, that's pretty nice. Good. And please choose the top right for carbon number 1 in this one, and don't choose the top right for carbon number 1 in this one. Choose this one or this one. When you do sigma rotations on chairs, carbon angles that used to be going up must become carbon angles that are going down. That's just how they look after you do sigma rotations of bonds. All right, so tell me what's on the up bond of 1 and what's on the down bond. And why is the up bond straight up? Because this angle's up, the axial bond is up. The equatorial, why is it slightly down the equatorial? Because axial was up. Equatorial slightly down, parallel to both this bond and this bond. And it's a little on the long side. So which one of these is the up bond and which one's the down? The H is up. Please put it up there. That's up. And the iodobutyl is down. 1, 2, 3, 4, iodo. 1, 2, 3, 4. Good. Now go to carbon 3. Which of these two is up? It's this one. Which one's down? It's this one. On 3, please draw the down bond first because the carbon angle points down. The axial is straight down. The equatorial bond is slightly up, parallel to both this bond and this bond. And that's up, neopentyl. 1, 2, chicken foot.
I think you're on carbon 2.
I'm on carbon 2. I called it 3 and it's not. Oh, that's good. That gives us more practice. Changes everything, by the way. Yeah. Yeah, it doesn't help when you're counting and you skip the number 2, right? Becomes a bad Monty Python sketch. All right. So what do we got? Carbon 3. What bond do you draw first? Forget everything I just said. I'm not going to edit it out because I think it was educational. I didn't draw anything wrong. I just drew it on the wrong spot, right? So which bond do you draw first? Always axial or equatorial? Answer, axial. Why? It follows the carbon angle that you already have drawn. If it's an up angle towards 3, axial is up. Therefore, equatorial is slightly down. And don't do that. That's slightly down, yes, but not parallel to the bond called 1, 2 or the bond called 4, 5. You're going to lose a quarter point. There. Parallel to that and parallel to that and slightly down. Has to be slightly down because axial was straight up. So that's where your neopentyl goes. And now my molecule cis, because I didn't follow my own instructions. The H is down, correct? The H is down. The dash equals down. The neopentyl's up. Somebody was going to catch me eventually. Glad I caught myself. This is up. Draw the neopentyl up there, please. There we go. And now we have 5 points. There's a lot of work for 5 points. I have to agree. The two groups that have carbon in them, tell me, is this axial or equatorial? The answer is equatorial. And the group here is axial up here. And that's good for another point. When I go to the other chair, the iodobutyl group better stay down in this one. And I don't know why I put a 2 there. I said do carbon 1, top right here, and carbon 2, 1 away from 1, but don't do carbon 1, top right here, do it there and then there. I think that's where my numbering stopped making sense. All right. Whew. Rough video, long day. All right, on 1 and 3, draw the bonds, axial first. Hey, both angles are down, right? And equatorial is next, parallel to the next bond, and parallel to the next bond. What I mean by next, parallel to not the next one, but the next one. So those are parallel. Similar story up here, not this one, but closer to that one. And this one's parallel to this one, and it's parallel to that one. And up stays up, so H up on 1. And H down on 3. Iodobutyl still down on 1, 2, 3, 4, I. Neopentyl still up on 3. That's just what chairs do. Up stays up, down stays down. Equatorial here becomes axial here. Axial here becomes equatorial up here. We're flying now. We got 12 points. Seems to speed up. And one quick point. That's a more stable structure. Remember, groups suffer from 1,3 diaxial repulsion. So in this conformation here, this group is suffering from a 1,3 diaxial repulsion with this H and the H that I didn't have to draw here. That's 2 carbons away. More importantly, this carbon here suffering from 1,3 diaxial repulsion with this H here and this H here. And this is bulkier because there's branching here, 2 carbons away from the ring. It's hard to get the whole thing away from the ring. This thing doesn't have a bulky atom until 4 carbons away. So like it did over here, it's like way away from the ring. Same here. I could have drawn a chair like and put the iodine there where it's nowhere near axial H's. So unbranched things are not bulky. You'll see many videos where bulky is talked about and defined. I don't want to redo that. I just want to come up with the test answer here. The one I circled, the bulkier, you'll see the wording is always the same. Please don't invent your own wording on these explanations. The bulkier neopentyl is avoiding 1,3 diaxial repulsion. I see students think they have a short form. They say the molecule doesn't suffer from 1,3 diaxial repulsion. Every cyclohexane in the universe suffers from 1,3 diaxial repulsion. This is a question that asks you to compare which 1,3 diaxial repulsions are the worst. And the ones in this molecule are the worst because that's the bulkier group. Bulky groups need to go equatorial. Boom. Other chair has that. So that's the whole question there. And I look forward to future questions you guys might have. Do you have anything about this question we just did?
Oh, no.
Yeah. So it's important to start down here to get the right structure. But it's worth it because when you do the, you want to have the right chairs to get your full points. And that's 10 points is nothing to sneeze at, right? So look at all of the previous, like the fall 21, the one previous to that. It's always the same, never changes. Just name changes. So you got to know how to do nomenclature. That's part of this question. And you got to know what R's and S's are. And you have to know how to do chairs. So there's a lot involved, but it's important because chairs are everywhere. They're all throughout nature, in your body. And that's all I got for that. So I'll wait for your guys' email, maybe do another one of these. Hey, tomorrow is our day, right?
Yep.
Q&A day. We can continue more tomorrow. So I'll see you tomorrow.
Thanks. Have a good night.
You're welcome. You too. Thanks. Adios.